So let's start with another question, which is product of array except self. You can read the question. It basically means that we need to, for example, let's look at the example, and for this one we need to uh, make a result in which every element of that array is multiplied except for the element itself. So in this case it's 24 because 2 times 3 times 4 is 24, and accordingly for every element. Now let's think of a brute force solution. What can be a brute force solution is that we can have nested loop, something like this, wherein the n is length of the vector, and inside this we'll have a j loop. And what we can simply do is we can define int product here, which will be equal to initially 1, and before that we need a vector int answer of size n, and we should also define n, which will be nums dot size. Okay, so if I is not equal to j, then I do product multiplied by nums of j. Because why I not equal to j? Because we don't want the same number to be multiplied with itself, right? And then when this loop is completed, we basically just write answer of I is equals to product. This is the most brute force approach. The time complexity of the solution is n squared, and it should pass the sample test case, but the solution should result in TLE when you submit it, because you can see the n can be as large as 10 raised to 5, and 10 raised to 5 into 10 raised to 5 is 10 raised to 10, which will give us TLE. So this solution won't work. Another solution is that you can multiply all the elements like this, and the difference should be that you will multiply everything but then later divide it by the number itself. However, in the question it is given that we should not use the division operation, and also it would be difficult for us, because what if the number is 0? If the number is 0, you cannot divide it by itself. So now let's think of a better solution. So if you look closely, let's look at this 3, for example. In the example 1, let's look at this number 3. So what should be the number, what should be result in this place? So we should multiply every number, and we should not multiply this 3. So 1 times 2 times 4, it should be 8. 8 is the answer. Now how did we come up with this answer? For this 3, we took whatever was on the left side of it and we multiplied it, and we looked at its right, and whatever numbers were there, we multiplied them, and then we multiplied this left multiplication and the right multiplication, right? So for each element, if I know what is its left multiplication and what is its right multiplication, then we get our answer, right? So let's write on that thought. So let's say the left product, let's write LP for left product, and for right product, let's write RP. Okay, I'm declaring of size n initially, and what will be the product of itself? So LP of 0 will be nothing but 1 always, because uh, for this 1 we are assuming that the multiplication will be 1 beforehand, so that we can multiply the rest of the numbers. It's a similar method, because whenever we want to find product of an array, we declare that variable, that product variable, we initialize it by 1, and for some we do it for 0, a general rule. Alright, and similarly for the right product last index should also be 1. Okay, so now let's fill our left and right product. So left product of a certain index I will be equal to left product of I minus 1 times the number itself, which is nums of I. And similarly, the right product will be equal to, the only difference would be we need to traverse it in a backward way. So it will be from n minus 2, since we already have result of n minus 1, up till 0. So the right product will be right product I plus 1 times nums of I. So now we have our left and right product. So for coming back to that example, for this number 3, what we did, if we have a right product of the numbers which are before this, and the left product of numbers which are before this, and we multiply themselves, what do we get? We get our answer on that index, right? So we'll just run a loop here from 0 to I less than n, I plus plus, basically write answer of I should be equal to left product of I minus 1 times right product of I plus 1. However, we can't do so because LP of minus 1 wouldn't exist. So let's do something like this here and something like this here. And we know that for extreme values, we can write answer of 0 to be equal to our right product of 1, and answer of n minus 1 to be equal to left product of n minus 2. Alright, everything's clear till here, because we are given the minimum length can be that of 2, so these both will have no problem running. And then we finally return our answer. Let's try running it. Oh, we are getting wrong answer, so we have messed it up somewhere. Let's see. So I initialized my LP and RP array. LP of 0 is equal to 1. RP of n minus 1 is equal to 1. I from 1 to n, and LP of I will be LP of I minus 1 times nums of I. So for let's do a try run. For this example, LP, let's write LP for this example. According to this code, it will be, initially I know it's 1, and then for index is equals to 1, I get LP of I minus 1, which is 1, multiplied by nums of I, which is 2. Okay, that is incorrect because we want, no, that is correct because we just want the product till that number. It should be that. Okay, I think I know what my problem is. So while initializing, it shouldn't be with 1, it should be with nums of 0. And similarly here it would be nums of n minus 1. Okay, let's try running it now. And perfect, we get why that was the case, because I want the exact number, whatever it is, on that index, because what I am assuming is the answer, the product of LPI should be equal to n minus, should be equal to till nums of I, the product. And when we are finding it for a particular index, we're just looking for its left and right product. So this solution would work. Let's try submitting it, but first let's discuss the time and space complexity of it. So what's the time complexity? We are doing this for loop here, we are doing this for loop here, and similarly we are doing this for loop. So there are 3 for loops of n. So overall time complexity for this solution would be O of n. What will be the space complexity? Space complexity, what are we using? We are using 2 vectors LP and RP, and so the space complexity will also be big O of 2n, right? So can we improve on this solution? First let's submit it. Can we improve on this solution? Well, if you observe one thing, we can clearly see that at a particular index we do need its left product and its right product. But is there any other way in which we don't use extra space for that? Well, I think there is. Okay. Let's just use the answer array itself, okay, and not the LP or the RP array. How do we do that? So if we look at this example again, let's understand how we got this 8 answer. Let's say that we are just multiplying it one by one. So, and I will store my answers in my answer array. So 1, initially 1 will be 1, 2 will be till 2, and 3 will be 6. Multiplication is just these 3 elements, right? So I know that answer of I is basically a prefix multiplication array, okay, initially. So answer of I should also consider the right product of it. And how do we write product? How do we keep track of the right product? We can just keep track of a variable, and then from that variable we will multiply whatever the value is at our current answer. We will multiply it with that variable. It will make more sense when I'm doing the try run, when I'm writing the code. Let's say initially answer of 0 should be 1 in this case, because here and here initially, I'll explain why that is the case. Answer of n minus 1 times n minus 1. So what this basically means is my answer of I currently, it just has my left product. Okay, this solves its left product. And now I need a variable for right product. So let's name it right product. I will initialize it with 1. Okay. Now let's come to this example again. For this 4, what should have been the answer? It should, because it doesn't have any right product, the answer should be just its left product, which is 6, right? So according to this code here, current value of answer of 3, which is pointing to this 4, is already 6. We don't need to do anything because the right product is not contributing to it. Alright, but if we look at this 3, initially this 3 has the left product of one element less, so it has the value 2 on this index for answer. But we also need to consider this 4. So we need to multiply my right product to this number, to this I plus 1 index when I am at I. Alright. So let's make things more clear by doing it here. I'll just erase all this. So initially my answer of I is nothing but a multiplication of its right product with itself. And at the same time, I want this right product to consider that particular element for the previous element, for the n-1th index. So this right product will be multiplied with nums of I. And now my answer will hold true. So I will just remove all these lines and let's try running it. So overall we didn't change our code much. Instead of using dummy vectors for right and left product, we are just using constant space. So we improved on the space complexity. The time complexity would still be big O of n. Now let's try submitting it. And this is also the most optimal solution for this problem.